Hello, students. Welcome to another video. Welcome to Tesseract Learning. Right. So, what is happening today? What are you going to do today? What's special today? What happened today? Let's catch up on it. So, today we had KCET exam, KCET exam, that is for Karnataka State Engineering Colleges, and we are going to discuss the physics paper of KCET that was held today. Right. Great, that is 23rd April today. So let us discuss. We'll be going through the questions one by one and we'll try to discuss, we'll try to understand the concept, we'll go for the detailed solution as well, right? Okay, so let's not delay it. Without any further delay, let's start. Let's start with the very first question, right? I don't understand why this is happening. What is happening? Something happened. Yes, now things are looking great. Fine. So let us have a look at the very first question. What is the first question? What I'm going to do is I'm going to simultaneously be taking screenshots and then doing it by taking a fresh page as well. Right? Fine. So let us have a look at the very first question. The very first question says, what does it say? It says, what is there on your screen, right? You can have a look and you understand, you decide what it says, right? Fine, let me zoom it 60%. I think now it is visible to every one of you, right? So the question says, a point charge is placed in a moving train. A passenger A sitting in the train and passenger B on the ground observes the field due to this charge. Then now, this is a very confusing. I'm sure many students must have gotten confused because this is something that is not taught in ordinary classes, especially at KCET level. I'll say this question, they have really tried to test your understanding to a deeper level, right? Although the paper, if I have gone through the paper does not look much difficult, but the challenge that happens in KCET that you have 60 questions in 1 hour, right? So that is a challenge, but having said that, the questions are not very difficult as such. It is doable. The questions in itself are not difficult, but time could be a constraint. But here and there, 1-2 questions are there which might push your thought limits, your thinking limits, and it might confuse you as well. And the very first question in this set is like that. Yes or no? What does the question say? The question says, a point charge is placed in a moving train. A passenger A is sitting in the train. So let us see, this is a train. What a train I have made. Good, very nice train. And here is the person A. So person A is inside the car, and let us say here you have a point charge Q which is inside the charge, inside the train, right? Now the question says, a point charge is placed in a moving train. A passenger A is sitting in the train and a person B on the ground. There is another observer here. There is another observer B who is on the ground. There is another observer B who is on the ground, right? So this is your observer B. Now what it says? So we have to see which option is correct. So see what is happening. The simple thing is, even if the train is moving with certain speed v, then the charge, since it is simply placed in a moving train, it will also have the same speed as that of the train. So with respect to train, with respect to A, velocity of charge will be 0. Velocity of charge will be 0. Why will it be 0? Because you have to see the relative velocity, right? You have to see the relative velocity, and the observer A is moving with speed v, same as the speed of the train. The charge is also moving with the same speed v. So if you take the relative velocity, it comes out as 0. So in frame of A, charge will be at rest. And now when charge is at rest, it only produces electric field. Now one very important concept you need to keep in mind, that every law of physics is valid in all the inertial frame. Inertial frame means whether the frame is at rest or moving with constant velocity, right? So as long as it is not accelerating, all the laws of physics are valid, right? So same way, even the laws of electrodynamics are valid. If you want to dive deep into this concept, you can prefer the David J. Griffith book. There they have explained detail. You will not find this kind of a content in normal books in general, but it is there in that book in detail. So this question, I will say, it is slightly, thought-provoking question, but again not very difficult as such. So the very first question, with respect to A, in frame of A, charge is at rest. So since charge is at rest, only electric field will be there, right? Only electric field. Great. Right. Now, in frame, so if a charge is at rest, it only produces electric field. Now, with respect to the observer B, observer B is on the ground. With respect to observer B, so observer B is on the ground, who is at rest. So with respect to observer B, the charge will have some velocity. Velocity of charge will not be 0, right? Velocity of charge will not be 0. It will be same velocity as that of the train or the wagon, yes or no? So in frame of B, what is happening? In frame of B, the charge q is actually moving, and if a charge is moving with constant velocity, you know that a moving charge will produce both electric field as well as magnetic field, right? So both, right, both ma'am, do you have that board where I can keep it, where we used to keep this one? Do you have that platform? Right, fine. So here what happens? So in this case, both electric as well as magnetic field will be there, right? Both electric and magnetic field. Right, great, fine. So here answer will be which option? Answer will be the second option, which is option B. So option B or option 2 is the correct answer here, right? Correct answer is, so let me write the answer here in the beginning itself, right? So here the correct answer will be the option 2, fine. So I hope this is clear. Let's go to the next question, right? We have a lot of questions to solve, so we'll try to do it as quickly as possible. Next question, what does the next question say? Yes, let us see it quickly. We have the second question. Let me paste it here and discuss it ASAP, as soon as possible, right? So pay attention on the second question, right? What is the second question saying? What does the second question say, right? Fine, let us see what it says. Second question says a proton, an electron and an alpha particle. So you have a proton, you have an electron, you have an alpha particle, enter at right angle to a uniform magnetic field with the same velocity. So you have proton, electron and alpha particle. It enters at right angles to electric magnetic field with the same velocity. So you have a region of space where you have magnetic field. So let us say this is the region of space, right, where you have uniform magnetic field, fine. Now here what happens? You are projecting a charged particle with certain velocity v, right? So we all know, what do we know? When the velocity is perpendicular to the magnetic field, here I have assumed the magnetic field into the plane direction, and you can see clearly v bar and b bar are perpendicular to each other. So when the velocity is perpendicular to the magnetic field, what happens? Charge moves in a circular path. Bang on, you're right. So here the charge is going to move in a circular path, something like this. Amazing, right? Now what happens here? Let's check it out. A proton and electron alpha particle enters at right angle to a uniform magnetic field with the same velocity. their velocities are same. Then you have to compare the radii. See, very simple formula. Formula for radius is mv by qb. Everyone knows it. If you don't know, you did not study. That's the only thing I would say. Very famous, very simple formula. Radius formula is mv by qb. Now, what happens? Here v is same, velocity is same, magnetic field is same. Same magnetic field, same velocity. In that particular case, radius is directly proportional to the ratio of mass by charge. Mass by charge. Fine. So let me do a quick summary for you. See, let us take mass of proton. Suppose mass of proton is m. Mass of electron will take me, which will be much less than m. Fine. Then you have mass of alpha particle. Mass of alpha particle will be 4 times m. Right, mass of alpha particle will be 4 times m. That's the thing here. Mass of alpha particle will be 4 times m. What else? Let us compare the charges quickly. So let us take charge on alpha particle, charge on proton, and just in terms of magnitude. Okay, let us say charge on proton is E. Then charge on electron will also be E. No difference there. Charge on alpha particle, it's a doubly ionized helium atom. What will you have? You will have 2E charge. Now, so we have to compare. So radius of alpha particle will be mass of alpha particle by mass of charge will be proportional to, it will be proportional to mass of alpha particle by charge on alpha particle. How much is the mass of alpha particle? 4m. How much is the charge on alpha particle? 2e. Fine. Now let us see. Radius of proton. Proton will be proportional to mass of proton by mass of alpha particle. Mass of proton, if I take it as m. Oh, why am I in a hurry? There's no hurry. I needed something, that a platform on which I used to keep and write. So fine, it's okay. We can do it without that as well. Now mass of, it's not mass, it's the charge. So mass of proton by charge of proton. So mass of proton, let us say m, charge of proton will be E, right? So this is 2m by E, this is m by E. You know, this is 2m by E, and this is just m by E. Now finally you have, what do you have? Radius of electron. Radius of electron will be proportional to mass of electron by charge on electron. Now you see mass on electron, let us say me, charge on electron is E. Now see here, pay attention. See, the charges E is directly comparable, but the thing is that mass of electron is much lesser than mass of proton. So it will be much lesser than small m. So here I can clearly see radius of alpha will be the greatest, then will be radius of proton. Here in this, if you compare the radius of proton and radius of electron, E value, the charge values are same in terms of the magnitude, but the mass of electron is much lesser. So mass of electron by E will be much lesser than mass of proton by E. Fine, I hope you are following here, right? So you can clearly see that the radius of alpha particle will be the greatest. Radius of alpha particle will be the greatest, then comes the proton, and then comes the electron. So that is that, this is this, who is who, I am who, you are who, right? That's the thing. So answer will be the second option. Again, correct. So answer here is the second option. Answer is the second option, right? Fine. Let's go for the next one. I hope it is clear. If not, you can always circle back. You can always pause the video, go back and forth, revise the formula and check it out, right? Great. So still have a lot of exams to give, BITSAT, BIT, SRM, MIT. Keep preparing. If one exam goes bad, it's not the end. It's not the end, my friend. Lots of opportunities to grab. Learn and move ahead. Don't sit back and think and overthink and dwell upon it. If you did good, very good. If you did bad, just revise and go for the next exam. That's the only suggestion I can give you as of now. Right, let's go for the next one. Third question. Right, what does it say? Biot-Savart's law. Again, this one also, in the first page itself 2-3 questions are there which could throw you off, which could make you feel that you know nothing, but that's not true. You know everything. Nothing new they have asked. You just have to channelize your knowledge and think a little bit, right? What are they saying? What does the question say? Question says Biot-Savart's law indicates that an electron moving with velocity v. What does Biot-Savart's law indicate? Let us revise Biot-Savart's law quickly. If you have a current carrying wire, then magnetic field due to a small current carrying element, the direction of the current carrying element will be along the tangential direction at any particular instant. This will be your IDL bar. This will be IDL bar. And if you want to find magnetic field at any point, suppose its position vector is this R bar. Position vector is, let us say, R bar, and then this angle is theta. Fine. Then Biot-Savart's law says that dB bar, the magnetic field at that particular point, dB bar will be equal to mu naught by 4 pi, mu naught by 4 pi, mu naught by 4 pi IDL bar cross R bar by R cube. Right? Now this is the formula. What does this mean? What does this mean? What does this mean? Let us see what it means. We'll see it very clearly, loud and clear. We are going to see it. See, dB bar is proportional to IDL bar cross R bar. What is the direction of IDL bar? See, current scalar quantity, no direction. DL bar we take in the direction of current. Now even if we consider the motion of electron, the only thing is that it will be in exactly opposite direction. Now, if you are considering because of an electron, the direction will be exactly opposite. Still, the direction of current will be in the opposite direction of the motion of electron only, right? So, IDL bar will be in the opposite direction of V bar. That's fine. But the point is, see, this magnetic field dB bar will be, you know the property of cross product. You know the property of cross product. Cross product of any two vectors is perpendicular to both the vectors. Yes or no? Cross product of any two vectors is perpendicular to both the vectors. Everyone knows it, right? And I'm sure you also know it. Cross product of any two vectors is perpendicular to both the vectors, right? So what happens here? So dB bar will be perpendicular to, dB bar is perpendicular to IDL bar. And IDL bar will be in the opposite direction of your V bar here, because it is electron. Here we consider the direction of proton, but it will be just opposite directions. Fine. If it is perpendicular to V bar, it will be also perpendicular to minus V bar, or if it is perpendicular to minus V bar, it will be perpendicular to V bar as well. And at the same time, this dB bar will also be perpendicular. This dB bar will also be perpendicular to what? It will be perpendicular to R bar as well. Okay, it will be perpendicular to R bar as well. Okay, let me just check. Everything is going fine. Everything is being recorded. There's no issue anywhere. Yes, so that seems to be the case. There is no issue anywhere. Okay, so moving ahead. Not moving ahead, continuing. So, right. So, what happens here? So, you can see that both will be perpendicular. So, B bar will be perpendicular to IDL bar. In a way, it will be perpendicular to V bar. Fine. So, answer will become B bar is perpendicular to V bar. V bar is perpendicular to V bar. So, answer here will be option 2. So, this implies that B bar is perpendicular to V bar as well. Fine. B bar will be perpendicular to V bar as well. That's the point here. So what will be the answer here? Answer will be option 2. Answer will be option 2. Great. Okay, great. Let us see the next one. Fourth question. Where is it? This is the fourth question that we have. Let me snip it out. Let me snip it out a little bit. Right. Maybe a slight adjustment is required in the zooming level. Let me zoom out a bit. Yeah, this way it's better. It's much better now. Is it better or not? Now it is better. Okay, fine. It's okay. It's a small hiccup point. Let's continue. Let's keep moving ahead. Right. So this is that. That is this. Okay. Let's go for the next question. Fourth question. Quickly. We have lots to go. Lots of them are there. Let's see this one. What is happening here? Fourth question says you have two identical circular loops carrying equal currents are placed with their axes inclined at 45 degrees to each other as shown. The resultant magnetic field at P. So I have two circular loops and we need to find resultant magnetic field at a point P. So let us see how to do this. Again, another simple question, but slight calculation may be required. So you have a circular loop like this and you have another circular loop like this. Now what happens? What happens is what you want it to happen. So because of this, magnetic field will be along the axis like this. Because of this also, magnetic field will be along the axis like this. So these two arrows you can think of as the magnetic field as well. So this becomes like the direction of B1 bar. This becomes like the direction of B2 bar. Fine. Right. Correct. Even the currents are flowing in the way that you can take it this way. Not an issue. Right. So what's there? Now we just need to find the value of magnetic field. See, magnetic field due to a current carrying loop is mu naught I into R square by 2 into R square plus X square to the power 3 by 2. This is the formula, right? Now here, how much is X? X is root 3R. So you can see for both of them, things are similar. Both of them, the value in terms of magnitude, the value will be same. So that becomes mu naught I into R square. So B1 and B2 both will be equal to B in terms of the magnitude. So mu naught I R square by 2 into R square plus X square. So R square is R X square R square plus 3R square to the power 3 by 2, which becomes mu naught I R square by 2 into 4R square to the power 3 by 2. So 8 into 8R cube, which becomes mu naught I by 16R. So individually they will create mu naught I by 16R. So both B1 and B2 will be equal to mu naught I by 16R. Now you can see that if I resolve into components, so B2 we can take two components. One will be along x-axis, B2 cos theta. One will be perpendicular to it, which is B2 sin theta. So B1, B2 both will be equal in terms of the magnitude, and that will be equal to B. So if I write the net magnetic field in vector form, what we will get? Let us see here. So B1 bar is completely along x-axis. So that will become B I cap. So you need to do B1 bar plus B2 bar. Net magnetic field will be B1 bar plus B2 bar. B1 bar is just B I cap. Whereas B2 bar will become, theta here is 45 degree. Theta here is 45 degree. So B by root 2 I cap plus B by root 2 J cap. If I take B common here, or if you want you can take B by root 2 also common, because that seems to be what they are doing in the options as well. So when you take B by root 2 common, taking B by root 2 common means you have to divide by B by root 2. So here root 2 I cap plus I cap plus J cap will be left. Now you just simplify this, put the values. B is mu naught I by 16 root 2 R, it will become, if I put the value of B, and here you have, if I take I cap common, root 2 plus 1 Let me take a bigger bracket. Root 2 plus 1 I cap plus j cap. So that is that. This is this, that is that. Great. So answer is option 1. Whosoever's paper is this, he has done a very good job. Most of the options are coming correct. So answer will be option 1. Right. Great. Fine. Let's go for the next one. This is the fourth. Next, fifth one. Let us see. Quickly. Ting, 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 ting. You have to do much faster. See, since I'm writing both all the steps, that's why it is taking time for me, but you can just go super fast and do it the way it is supposed to be done in the exam without losing much time. Okay, great. See here, fifth one, this question, what does it say? Right, if a paramagnetic bar is brought near a bar magnet, then it is, what happens? So if paramagnetic substances get feebly attracted to magnets, whereas diamagnetic gets repelled, ferromagnetic gets strongly attracted. So it will be attracted. Okay, it will be attracted by both the poles of the bar magnet. Okay, it will be attracted by both the poles of the bar magnet. Right. So see here, like if you have a bar magnet this way, north, so it moves in the direction of stronger magnetic field. As it doesn't depend whether it just moves in the direction of the stronger magnetic field. That is the case. So if the magnetic field lines are like this, coming out, going in, it does not matter. It will move from stronger magnetic field region to weaker magnetic field region to stronger magnetic field region. So near the poles, the strength of the magnetic field will be high, so it will be getting attracted towards both the poles. Fine. So here answer will be attracted by the poles of the bar magnet. Okay, here the answer will be option 1. Fine. Answer will be option 1. Okay, great. Fine. Let us see the next one. Fifth one. Let's see the sixth one. Sixth. Okay, great. Let's see what it says. Let's see. Okay, great. Sixth. Quickly. We gotta do it. Right. So this is the question. The number is not there. It's there. This is the fifth question. Okay, this is the fifth question. Just keep that in mind. Starts from here. Pick out the wrong statement about magnetic substances. Fine. So see, mu r is 1 plus magnetic susceptibility. Okay, mu r is 1 plus magnetic susceptibility. Now what happens for diamagnetic substances? Mu r is less than 1, so it's a negative value. For diamagnetic substances, it's a negative value. Okay, fine. Pick out the wrong statement. We need to figure out the wrong statement. Find substance with so for diamagnetic substance, this is correct. Diamagnetic substances will have the magnetic susceptibility. It will be negative, but small value. It will not be very large negative value. The idea is that mu r should be less than 1. Okay, for diamagnetic mu r should be less than 1. Fine. Great. For mu r to be less than 1, the magnetic susceptibility should be negative. It should be just less than 1. It should not become negative 5, 3, 4 like that. So this magnetic susceptibility will be between -1 to 0. So that's correct. Fine. Substance with much greater than 1. No, it is. So what happens is for For paramagnetic substances, the magnetic susceptibility is positive small value. Okay, for paramagnetic substances, magnetic susceptibility is positive but small value. It is not a very large value. So this is wrong. Okay, option 2 is wrong. Substance with x much less than 1 are for ferromagnetic it will be much greater than 1. Okay, for a ferromagnetic substance it will be much greater than 1. So this is also incorrect. Substance with mu are much greater than 1 are ferromagnetic. This is correct. So here our answer will be, we need to identify the wrong statement. So answer will be option 3. Okay, answer very well will be option 3, right? Great. Let us see the next one. Next one we have the 8th question. Not the 8th. We are still in 5th. Let us see the 6th done. Oh, that was the 5th. This is the 6th question. Okay, mistake. 6th question. Fine. The 7th question. What does the 7th question say? Work function of the metal is. What is the work function? It's the minimum energy required. It's a definition only, right? It's just a definition, direct definition they have asked. 7th question is easy one. Work function indeed is the minimum energy required by the electron. Fine. So answer will be the option 3. For 7th one also, answer will be option 3. So minimum energy required to just eject an electron from. Correct. That's so third option. The direct definition only work function. It's a simple question. Let us see the 8th one. Variation of photoelectric current with anode potential is shown below. Right. So we have seen this graph again and again, how the current depends upon the potential. So if we increase the potential, the current is not going to increase beyond a certain value. Okay, if you increase the potential, the current is not going to increase beyond a certain value, which is the saturation current. But if you decrease the potential, then for a certain negative potential, the current becomes 0, and that negative potential is referred to as stopping potential. Okay, that negative potential is referred to as stopping potential. Fine. So the graph here very well will be the option 1 graph only. Okay. So if you keep on increasing the potential, the current is not going to increase beyond a certain value. The graph is more like this. Fine. But for a certain negative potential, the current becomes 0. That is the stopping potential. So here the answer will be option 1. Right. Answer will be option 1. So that's that. Right. 8th one. 9th one. What does the 9th one say? In Faraday-Henry experiment, a coil is connected to a galvanometer. For deflection pointer, right, let us see the 9th one. 9th question. In Faraday-Henry experiment, a coil is connected to a galvanometer. For the deflection pointer in the galvanometer, which of the following statements is wrong? A coil is connected to a galvanometer. For the deflection pointer in the galvanometer, which is following: when the bar magnet is moved towards the stationary coil, the pointer in the galvanometer deflects. When the bar magnet is moved towards the stationary coil, when the bar magnet is moved away from the stationary coil, the coil is moved towards the stationary bar magnet along its axis. When the coil and the magnet are moved without relative motion. So see, if the idea here is the flux should change. Here what should happen? For EMF to be induced, flux should change. So in option D, the flux will not change. Answer will be only option 4. Which is the wrong they're asking? Which of the statement is wrong they're asking? So answer will be the 4th option. Fine. Clear. Answer will be the 4th option, because no change in flux. No change in flux in option D. Right? Clear? Fine. 9. 10th one. 10th one, you see what they are given. In the figure shown, the conductor PQ. Great. Let us see the 10th one. Let us see quickly. What does the 10th one say? Great, it says a lot of things. But we have to see what that says. Right. 10th question says in the figure, the conductor PQ of length L is moved from x equal to 0 to x equal to b and then up to x equal to 2b with a constant velocity v. An uniform magnetic field is perpendicular to the plane of the paper and extends from x equal to 0 to x equal to b, and it is 0 from greater than b. The magnitude of EMF induced in the circuit is. So see, mostly EMF will be induced. Mostly EMF will be induced as long as the magnetic field is there. Mostly EMF will be induced as long as the magnetic field is there, or you can say in terms of loop, as long as the flux is changing. So you can see here, as long as it is moving from x equal to 0 to x equal to b, in that region the flux changes, right? So between, when x is between 0 to b, flux changes. So EMF will be induced. EMF induced will be equal to BVL. EMF induced will be equal to BVL or BLV. But for x greater than b, less than 2b, EMF will not be induced because the flux does not change. No change in flux. If flux is not changing, EMF induced will be 0. EMF induced will be 0. Fine. So what will be the answer here? Answer will be option 3. Between 0, okay, correct. BLV. B, what is x? No, not BLX. BLV. Between, yes. So answer will be option 3. Answer will be option 3. Again, this is a simple question here. So a very simple question, right? Let's move on. Let's move on quickly. 11th one. What is the 11th one says? In a circuit containing a pure resistor connected to an AC source. So when you have a pure resistive circuit, voltage and current are in same phase. In case of pure resistive circuit, voltage and current are in same phase. So answer will be which one? Answer will be option 3. There is no doubt there. Voltage and current are in same phase with each other in case of purely resistive circuit. There is not much to discuss there. 12th one. What does the 12th one say? Let us see. A light bulb rated 100 watt is connected to an AC source of 220 volt. The RMS current. Okay, let us see. Let us go through this 12th question quickly. A light bulb rated 100 watt is connected to an AC source of 220 volt 50 Hz. The RMS current through the bulb is. Right. So light bulb is a pure resistor. Okay, light bulb is a pure resistor. Now, what do you need? You need the RMS current. So average power is VRMS, IRMS, cos phi. Here a light bulb is just a resistor, so cos here will be 0 degree. Fine. So average power they have given 100 watt. VRMS, so this value that they give is nothing but VRMS only. Yeah. So VRMS is 220 into IRMS. Keep this in mind. The value that they gave is nothing but the RMS value only. Peak value will be 220 times root 2. The rated voltage that you have, that is the RMS value only. So IRMS will become 100 by 220. Now how much that becomes? It gets cancelled. 5 by 11. 5 by 11. You divide 5.04 times 44. 6 times. So not 6 times, 5 times. So it seems close to 0.5 0.454 ampere. So answer will be option 1. Okay, answer will be option 1. The speed is the key here, right? Clear? Fine, let's go for the next one. So answer will be option 1. Just power, average power is Vrms Irms cos phi. A bulb is just a simple resistor. Phi will be 0 degree here. Moving ahead, let us see the next question. 13th one. 13th one seems calculative by the looks of it, but let us see what is happening here. 13th question. Let's go, let's go, let's go. Power through, power through. Okay, what is happening in the 13th question? 13th question says, what does it say? Let us see. What does it say? Solution. A small town with a demand of 900 kilowatt of electric power at 220 volt is situated 20 kilometer away from an electric power generating station. The two-wire line has resistance per unit length of this much. The town gets power from the line through 45,000 volt to 20 volt step down transformer at a substation in the town. The line power loss in the form of heat. So we just need to figure out the amount of heat generated. Heat will be generated because of the I square R. Okay, so you need to look at the I square R part. Fine. So fine, how much is the power? Power is 900 kilowatt. Power is 900 kilowatt and power is V into I. Fine. So power is 900 kilowatt, 900 into 10 to the power 3. So voltage, so this is the demand of 900 kilowatt at 220 volts. So it will consume 900 kilowatt when the voltage is 220 volts. So 220 into the current. So current value will become 900 by 220 into 10 to the power 3. So 0 gets cancelled. 90 by 22, 45 by 11 into 10 to the power 3. Fine. Now what will be the power loss? Heat generated. Power only they are asking. Heat generated in the form of heat per unit time, no? Because if you see the unit is in power. Fine. The heat generated per unit time, basically the power loss you can say, will be I square R. Little bit of calculation is there here. So 45 by 11 into 10 to the power 3 whole square times R is situated 20 kilometer away, and two wire line has resistance per unit length. So that two wire line, so into 2 into 5 into 10 to the power minus 4 into the length, which is 20 into 10 to the power 3. Quite a bit of a calculation here. Now 45 into 45 by 11 into 11. Right, I hope things are going well here. Okay. The town gets power line through at a substation in the town. Okay. Sorry. Mistake. So here, see, the power is being supplied. It is being supplied at high voltage as 45,000 volt. But when it reaches near to the town, then it gets stepped down. Okay. So the current that we need is when the voltage is. Sorry. I made a mistake. We have to consider. See, power loss will be happening during the transmission before it reaches the town. And you can see one important point they have given. The town gets power through the line through 45,000 volt to 220 volt step down transformer at a substation in the town. So the step down is happening near the town, whereas the transmission, during transmission the voltage is 45,000 only. So mistake there. So power is 900 into 10 to the power 3. Voltage is 45 into 10 to the power 3, I can write, into the current I. So this gets cancelled. Current will become 900 by 45, which will become 20 ampere. Fine. So that's that. Now power loss becomes I square R. So I square will become 400. R will be 5 into 10 to the power minus 4 into 2 into 20 into 10 to the power 3. Right. Great. So this you can cancel out. So 5 fours are 20, 2000 into 4, which is 8 into 10 to the power 3, so which is 8 kilowatt. Fine. Since a two line structure, it should be 8 kilowatt. This is where a mistake has happened from the student, I believe. So answer will be the option 2, right? 4 into 2, 8. Yes. So answer will be option 2. Answer is option 2. Fine. If there's no calculation mistake anywhere, let me quickly check. I square, it's 2, 4, 5 for the 20, 2 to the 4. So 8, the factor of 8 is indeed coming into the picture here, and yeah, sounds good, looks good. 8 kilowatt. Fine. So slightly calculative, slight confusing as well. Okay, good question. Let's move on. We don't have time. We have lots to discuss. Lots and lots to discuss. So many questions. Where to do, how to do, when to do or not to do. Everything is required. Right. Okay. 14th one. See. 14. What does the question say? Match the following Maxwell equation. We have to just match the equations. Gauss law of electrostatics. Gauss law of electrostatics says here net flux is Q enclosed by epsilon naught. So this will be matched to 1. Fine. Gauss law of magnetism. Net magnetic flux is 0. This will be matched to 3rd. Faraday's law. It says that EMF induced is equal to rate of change of magnetic flux, which is this one. Ampere Maxwell law is this one. Ampere's law, and then including the displacement current factor. So answer here will be option 1, right? Answer will be option 1. Fine, clear. 14. Now what do you need? 15, right? 15 is a simple thing. Let's do it. Let's do this. I'm tired now. I'm legit tired now. Guys, what is happening? Let's power through. We have lots to discuss. A lot of questions. I don't know how you guys doing. Not so easy. It's not that easy, you know. If you have done well, you know, celebrate yourself. With reference to the figure below, match the following. Angle of reflection. How much will be angle of reflection? Angle of incidence is 30. Angle of reflection will also be 30 degree. Right? Now, what else? Value of alpha. How much will be alpha? Alpha will be 90 minus 30, which is 60 degree. Right, great. Seems like someone is at the door. Let me check once. I don't think so. Right. Okay, great. Fine. Now, angle of deviation. How much will be deviation? Angle of deviation is delta is 180 degree. 180 degree minus 2 times the angle of incidence. (180 degree minus 2 times 30). How much is 2 times 30? 60. 180 minus 60 becomes 120. Right. Okay. So angle of reflection. Angle of reflection is 30 degree. Great. Value of alpha is 60 degree. Great. Angle of deviation is 120 degree. So mark correctly 3B1 C. Sorry. A is marked with 3, B is marked with 1, C is marked with 2. So he has marked correct only. So answer will be option 3. Right. So answer is option 3 indeed. Right. Okay, great. Let's go for the next part. This one. What does it say? 16th question. The direction of let us please check it out. Sixteenth question. The direction of a ray of light incident on a concave mirror is shown by PQ, which direction is which the ray would travel after reflection is shown by 4 marked arrows A, B, C, D. Shown here. Which of the four rays correctly show the direction of the reflected ray? So reflected ray, if this is the incident ray, this is how the reflected ray will be. If you take a ray parallel to principal axis, after reflection it passes through focus. Fine. So which one? C is correct. So here answer will be option 2. So simple question. Right, answer will be option 2. Great. Solution answer 2. Okay, moving ahead 16. Next you have 17. The incorrect statement about refractive index of a pair of media is, which one is the incorrect statement here? Fine. The incorrect statement about refractive index of a pair of medium, it depends it depends on the material. Okay. The incorrect statement about refractive index for a pair of medium, it depends upon nature of the first medium, it depends upon the nature of the second medium, it depends upon the wavelength of light. Fine. That's all true. It depends upon so it's a property of the medium as well as the wavelength of the light. It does not depend upon the right. We have this Cauchy's formula, right? We have Cauchy's formula which says, what does it say? Cauchy's formula say that mu is equal to A plus B by lambda square plus C by lambda to the power 4 and so on, where A, B, C are constants, right, depending upon the material. So it depends on the wavelength as well. Roughly you can say inversely proportional to wavelength. Fine. So but it does not depend upon the angle of incidence. So here the answer will be option 4. Right? Great. Let us see the next one. 18th. What does the 18th question say? The critical angle of a monochromatic light. Okay, quickly we'll see. We'll try to finish it off. Sorry. Right, the critical angle for a monochromatic light going from medium A to B is theta. If the speed of light in medium is V, then the speed of light in medium B is, okay, see, critical angle is sine inverse of mu rarer by mu denser. Fine. Now, so critical angle here is theta. That will become sine inverse of, which is the rarer medium. So light has to go from denser medium to rarer medium for total internal reflection to take place. So for critical angle to be defined. So going from medium A to B means medium A is the denser medium, medium B is the rarer medium. So mu of B by mu of A. Fine. Now the next step, theta will be sine inverse of mu of B. How much will be the mu of B? Great. So see, mu is c by v, mu is c by v, so mu b by mu a will become va by vb, va by vb. It becomes sine inverse of va by vb. Fine. So critical, if the speed of light in medium a is v, then the speed of, so va is v, we need vb. Fine. So sine theta will become v by vb, vb will become v by sine theta. Okay, vb will become v by sine theta. So this is absolutely correct. So answer here will be option 3, right? Okay, great. Moving ahead quickly. We'll see 19th one. What is the range of electromagnetic spectrum to be considered as light? So the portion of visible rays, electromagnetic, the portion of electromagnetic spectrum which is sensible to our eye is called as light. So basically the Vibgyor part only is considered as light. So here for violet the wavelength is 400 nanometer. For red, and you have this light is nothing but these all colors. So for violet it is 400 nanometer, for red it is 700 nanometer. So answer will be option 3. Fine. Okay, great. Let's go for the next one. This is the 19th one. Next, 20. What does it say? Let us see. 20. Quickly. In a Young's double slit experiment, how many maxima can be seen on a screen if d is 5 lambda by 2? So see here. So the maximum path difference that could happen, okay, the maximum path difference that could happen is the separation between the slits. This is a concept you need to keep in mind. Like if you have these two slits, here the path difference will be 0. As you are moving up, the path difference will be increasing and it becomes maximum at infinity. So rays will appear like this, and if you see the difference, this delta x max will come out equal to d only. Fine. So delta max is equal to d, which is 2.5 lambda. So how many maximas are possible? How many maximas are possible? See, 5 maximas are possible, because if this is the screen, at 0 you will have a maxima, at lambda you will have a maxima, at 2 lambda you will have a maxima, 3 lambda not possible, because maximum path difference we can get is 2.5. So here as well as here, at bottom also, below the central maxima also you could get, right, 2 more. So 2 above central maxima, 2 below, so overall 5 maximas will be there. So here the answer will be option 1, which is 5, right? Great. Let us see the next one, 21. What does it say? What does it say? Let us see quickly. Let's not waste time. Fine. 21. What will it say? It will say what I wanted to say, right? So the radius of first orbit of hydrogen atom is this, the kinetic energy and potential energy. So this is a very well known value. We don't need to do much. The energy of any orbit is given by the total energy in general. The total energy is minus 13.6 Z square by N square electron volt. Fine. So for the first orbit of hydrogen atom, the total energy will become minus 13.6 electron volt, because here Z and N both will be equal to 1. Z will be 1 and N will also be equal to 1. Fine. Now we know that the potential energy is 2 times the total energy. Potential energy is 2 times the total energy. First let us start with the kinetic energy. Kinetic energy is negative of total energy. Kinetic energy is negative of total energy, so that becomes 13.6 electron volt, and the potential energy is 2 times the total energy, which will become minus 27.2 electron volt. So kinetic energy should be 13.6, potential energy should be minus this, total energy will be this. So answer will become option 2. So answer is indeed the option 2. Fine. Clear? I hope no confusion there. Quickly, 22. What does 22 say? Bohr's second postulate implies. What does the second postulate say? That MVR is equal to NH by 2 pi. Simple thing. Bohr's second postulate says that MVR is equal to NH by 2 pi, which is basically the quantization of angular momentum. MVR is angular momentum and MVR should be equal to NH by 2 pi. So here the answer will be option 3. Fine. Right. 22, 23. Now what does 23 says? An electron transition takes place from excited state to ground state, then. Okay, great. So we have to do a little bit of analysis here. Not an issue, not an issue. Let us check quickly. Simple yet effective question. An electron transition takes place from so its kinetic. See, total energy is minus 13.6 by n square electron volt. Fine. If I am considering the hydrogen atom, Z is 1. Now potential energy is 2 times the total energy, so minus 2 into 13.6 by n square electron volt. It's fine. Kinetic energy is negative of the total energy, so 13.6 by n square electron volt. Fine. Now what is happening? An electron transition takes place, so n is decreasing. N is decreasing. So see, if n decreases, this value will increase, but it will become more negative. So if it becomes more negative, this will also decrease. Think about it. Fine. Potential energy, if n decreases, this value will increase, but since it is negative, it becomes more negative. So more negative means it decreases. This one, n decreases, this value will increase, and since this is positive, this is also going to increase. So its kinetic energy increases, but potential energy and total energy will decrease. Think about it. That's what I'm saying, the hint. If a value becomes more negative, then it will decrease, even though the value is increasing, but since it is becoming more negative, we'll say that it is decreasing. Great. Fine. Let us see. 23, 24. What does 24 says? An n-type and p-type semiconductor can be obtained. Oh ho ho. This is a factual question. You need to remember this. This is the NCERT. Fine. What are they given? An n-type. For n-type, you need to dope it with pentavalent atom, and for p-type, you need to dope it with trivalent atom. So boron, indium. See, phosphorus is pentavalent. So for n-type, what do you use? Phosphorus. For p-type, and so this data is there in NCERT. This you can check it out. You have to just check it out a little bit. NCRT physics, semiconductor. See here. For N type, what do we use? And for P type, what do we use? So you have the pentavalent atoms, phosphorus, arsenic, antimony and phosphorus are the pentavalent atoms. Trivalent are indium, boron and aluminium. These are the trivalent. For P type, these are the ones that we'll use for N type. So this data is directly there in NCERT. You have to check it out yourself. So arsenic, antimony and phosphorus are, what do you say? Right. For N type, so for P type you need boron or aluminium. So here you have boron or aluminium. Fine. Arsenic, antimony and phosphorus. So here answer will be option 1. Right? Not the one which here. So, okay, N type and P type. So for N type you should have phosphorus. Phosphorus, aluminium not required. So this is not correct. This is also not correct. Between 2 and 3, phosphorus and indium. Indium, I'm not sure whether they have mentioned. Have they mentioned about indium? Okay, so indium, boron and aluminium are the trivalent. So for P type you need indium. For P type you need indium. Okay, you need indium for P type, not for N type. So right, so answer will be option 3. Actually I got confused with what he has marked. So here answer will be option 3. Fine. So you can check it out in your NCERT. They have given this data directly. Sometimes even I forget what happens. You must keep revising, no, before the exam. Fine. Right, so phosphorus is used for N type and indium is used for indium, aluminium and boron. For P type you have boron, indium and aluminium. Fine. Fine. So answer here will be option 3. Fine. So for N type, I'll write it here. For N type we use arsenic, antimony, and phosphorus. Right. For P type we use boron, indium, and aluminium. Fine, so this data you need to remember. Okay, right. Let us see the next one, 25th one. So that's there. 25th one, in which of the following the diode is reverse biased? So in whichever the p type is at higher potential than n type, it will be in reverse bias mode, right? P type should be at a higher potential than n type. Fine, p type should be at higher potential than n type. That will be the reverse bias. So this is p, this is n, this is forward bias, not this one. This is p, this is n. So p type should be at reverse for p type should be at lower potential, n type should be at higher potential. So minus 10 is in fact greater than 20, so this is correct. This is forward bias, this is also forward bias. So answer will be option 2 here. Answer will be option 2, right? Clear? Okay, 25. Let us see 26 quickly. 26. Okay. 26. What does it say? Fine. A wafer of pure germanium crystal has two parts, X and Y. The end X is obtained by doping arsenic and Y is, so arsenic, antimony and phosphorus, this is for P type, and indium is for, so this is for N type and this is for P type, right? So arsenic is N type, Y is your P type, correct? So this mention is correct only. So X is N type and Y is P type. Okay, and the junction is reverse bias because N type is at higher potential, P type is at lower potential. So this is reverse bias, correct only. So here answer will be option 4. Fine, answer will be option 4 here. So that's for 26. Clear? Next we have what, 27. 27, let us see, what does it say? Right, from the graph of angle of deviation versus angle of incidence for an equilateral prism, refractive index. So you have this formula. What is the formula? Mu is sine of delta m plus a by 2 whole divided by sine a by 2. This is the formula. We can use it directly. So sine of, so you can see from the graph, this is the minimum deviation here. So minimum deviation will be 60 degree. So 60 degree plus, it's a equilateral prism. So angle of prism will also be 60 degree. So 60 degree plus 60 degree whole divided by 2 divided by sine of 60 degree by 2. So this becomes sine 60 basically. Sine 60 is root 3 by 2. Sine 30 is 1 by 2. So mu will come out equal to root 3. Fine. So here answer will be option 3. Fine. Correct. So answer is option 3 here. Right. Fine. Let us go for the next one. 28. Which of the following is correct for verification for Ohm's law? So in Ohm's law, what we will do? We will measure the voltage and current properly and will plot a graph. So we have to just see that which of the graph is measuring the voltage and the current properly, right? Let us see quickly. Fine. So to measure the voltage, you should connect the voltage voltmeter in parallel and ammeter in series, right? And this is the higher potential, this is the lower potential. So plus should be on the left hand side. So second option is correct. And here you can see ampere they are connected in parallel. Here again this is not right. Ammeter is connected in series, whereas voltmeter is connected in parallel with the polarities. This is the right, plus minus, right? So here the answer will be option 2. Answer is option 2. Great. Right, 28. Next is 29. Match the following. Great. We'll see quickly we'll see for 29 what can be done. Right. Okay, great. We have to just match the options. Torque is force into perpendicular distance, so the dimension of torque will become, force is mlt minus 2, so ml squared t minus 2, mlt minus 2 into L you have to do. Gravitational constant G, so F is G m1 m2 by r square, so fr square by m1 m2. So the dimensional formula for G, for force you have mlt minus 2 r square will be L square by m square, so this becomes m to the power minus 1 L cube t to the power minus 2. Fine. Next we have capacitance. Q is equal to CV. Q is CV, so C becomes Q by V, charge stored per unit potential difference. So the dimension for capacitance, charge will be A into T, current into time, potential is work done per unit charge, work is ml squared t minus 2 by AT only will come, because it's work done per unit charge. So this will become m to the power minus 1 L to the power minus 2 t to the power 4 a square, right? Planck's constant, E is h into f, h will become E by f, right? So dimensional formula for h, energy is ml squared t minus 2, any kind of energy ml squared t minus 2. Frequency is 1 by t time period, so t to the power minus 1, so ml squared t minus 1, right? ml square t minus 1. Okay, let's quickly match. Torque, ml squared t minus 2, fourth one. Gravitation constant, m minus 1, this one, third one. Capacitance, bigger one. Planck's constant, this one, right? So first should be 4, second should be third should be 1, so that is happening in option 2. So answer is option 2. Answer is option 2 here, right? Great. 29 last, let us see. Fine, so we'll discuss 30 questions only in this session. I have exercise in the evening. I'm very much tired, not getting the energy, a lot of questions to discuss. 60 questions, not a joke. Great part to you. You all are great, doing so many questions at one go, right? Okay, fine, let us see. I'm doing it by standing and I just exercise, so that is also a reason. Great. So this is cover first half distance and second half distance. Average speed, V average becomes what? 2 v1 v2 by v1 plus v2. So equal distance interval 2 v1 v2 by v1 plus v2. So 2 into 40 into 50 by 40 plus 50. So 2 into 40 into 50 by 90. 0 0 gets cancelled. 5 2s are 10. So 400 by 9. So 9 3 times 36. 9, so 9 4 times 36. So 44.4, like that it will come, right? So answer will be option 2. Fine, right? Great. So in this session I'll discuss 30 questions only. 30 more questions are there that I'll discuss in the next session tomorrow. Okay, tomorrow I'll be discussing the rest of the questions in the next video. Fine, there are a lot of questions. I'm tired now, it's late at night. I'm really sorry. I'm feeling sleepy. Okay, students, thank you for watching. keep supporting, keep loving, keep learning. All the very, very best, right? Okay, bye bye, bye bye, bye bye, bye bye, bye bye, bye bye.